Okay, so we're live. So George should be coming very soon.
Do you want me to put it in the baggie for you, or do you want to just eat it?
Okay, so for week 1, or for this is week 10, for problem 1, the figure 11.4 shows a glass of ice water filled to the brim. Will the water overflow when the ice melts? Explain your answer.
I said no.
It won't?
Yeah, like because of the displacement of it, it won't take up more space when it melts than it did when it was frozen. That's what I said.
Yeah, I basically said the same thing. I mean, when water melts, it expands. So even if it's poking up a little bit over the glass, it bends back down to its original. And I watched a couple of videos of them kind of experimenting, and they proved it. So
I can see that. Oh wait, because the density doesn't change at all. So we would just do the same. Okay, number 2, a 2.5 kilogram still gasoline can full liters of gasoline when full. What is the average density of the full gas can, taking into account the volume occupied by steel as well as gasoline?
I got 793 kilograms over m to the third.
that's also what I got.
But I kept reference for each. I just did the 2.5 divided by the 20.
Same thing, different units. Okay, so 3.
How much force is exerted on one side of 8.5 centimeter by 11 centimeter sheet of paper by the atmosphere? How can the paper withstand such a force?
I can write down how it can withstand such a force. 947 newtons.
Yeah.
What'd you get?
947 newtons.
That's not what I got, but if you both got it, then it's probably right.
Yeah.
I got 94,700.
94,700.
Mm-hmm.
So same numbers. Let's
Just
see. Pascals, 0.11 meters. What are we given? So change 10 meters to meters, so 0.11 meters, right? 0.085 meters.
Mm-hmm.
Is there something I'm missing here? Did you just multiply those? Atmosphere pressure, meters.
And you kept this. This is
Let me put it in my calculator.
101,300. Or did you put this as?
Is one ATM 101300 or is it 101.3 or something like that?
So it should be, well, in pascals, it's 101,300. It's 101.3 kilopascals.
Okay.
So like that's right. I think it's just the.
What did you get, Whitney?
Nothing close to that. I got 6.11 times 10 to the third. I think because I converted one of them into meters, but I didn't convert the other one. So I think that's how I got it wrong.
What number are you guys on?
We're number 3.
What did you get, George?
944.3 newtons. Huh?
So you were saying that this is wrong. 101.300 is not pascals. That's pascals.
No, that's pascal. That's pascals.
Okay.
So you're right there.
So what I did, I was multiplying so at first I found the area.
Right.
Right, and then I did force equals pressure times area. Yeah.
You're just asking in general, why is it? That's the whole
That's how that works. But I mean, I don't know if I'm right.
No. Okay.
You're approaching
That's what I did. Okay. So I converted it. Yeah. So yours is right. It should be 947,000 or 947 units. So I just divided by 100, which works if it's linear, but it's an area. So that's my conversion is wrong right here. So I'm missing a couple more zeros. It could change.
Yeah, your numbers are
Doesn't-
that makes sense.
Yeah.
All
So
right.
it should be the 947.
Okay, so number 4. What force must be exerted on the master cylinder of a hydraulic lift to support the weight of a 2,000 kilogram car resting on the slave cylinder? The master cylinder has a 2 centimeter diameter, and the slave has a 24 centimeter. So I got 136 newtons.
That's what I
I
got.
thought as well.
So just did force 1 over area 1, force 2
Oh.
over area 2.
I have multiplied. That's what's trying to change it.
And it's a kilogram, so we'll multiply that by 9.8.
Right.
Okay.
So I just mixed up the division. Okay. Number 5. Marbles dropped in a partially filled bathtub sink to the bottom. Part of the weight is supported by buoyant force, yet the downward force on the bottom of the tub increases by exactly the weight of the marbles. Explain why.
So what I said was, I mean, although like the balls would like the marbles would weigh less in the water, and the weight doesn't go anywhere, and like the tub is like outside of the water, so it's still it feels the pressure of the water plus the marbles and like everything in it. Does that make sense?
Yeah.
Perfect.
Okay. Number 6. In an emergent measurement of a woman's density, she is found to have the mass of 62 kilograms in air, an apparent mass of 0.085 kilograms when completely submerged with lungs empty. What mass of water does she displace? What's her volume? Calculate the density. Her lung capacity is, yeah, whatever.
So for A, I got 61.915.
Yep.
And then B, I got 0.061915.
Okay, yep. I just got that.
Okay. And then 1.00. I can't read if it's a 4.
0.001.
I wrote it really messy.
It should be like a 1.
1.00.
Yeah.
Okay. And then times 10 to the third. And then D, 972 point. Wow, my handwriting's bad. 548. I did it really fast.
Well, these no.
Oh, sorry.
So is she able to float or not?
Okay.
I said yes because it's less than water, which is 1,000.
Right.
Yeah. So it's just a yes or no. All right. Number 7. A major artery with a cross-section area of 1 centimeter squared branches into 18 smaller arteries, each with the average cross-sectional area of 0.04 centimeters squared. At what factor is average velocity of the blood reduced when it passes into these branches? So I got 0.14.
Yep. Same.
So
Which one? I don't know what you got. What did you guys get?
0. So it increases by a factor of 4.
Bless you.
Thank you.
Sounds good. I don't think that's what I got. Perfect.
Because you can ignore the two velocities, and then it's just a ratio of 1/18 times 0.4, because it's the ratio of like the major artery is one area, and then all the other arteries added together, and that's where the ratio is from.
Perfect.
Okay. Number 8. Some chimney pipes have a T shape with a cross piece on top that helps draw up gases whenever there's a slight freeze. And explain how this works in terms of Bernoulli's principle. So that one's where like the faster a fluid's moving, the lower the pressure goes, is the principle. So when fluid or air moves across something, it decreases the pressure. So the pressure at the top of the pipe is lower than the pressure at the bottom of the pipe, and it just creates a vacuum. It sucks it up.
That's an airplane too.
So they're moving across, creates a lower pressure at the top of the pipe than at the bottom of the pipe, and it just sucks it up. Okay. Number 9. A sump pump used to drain water from the basement of houses built below the water table is draining a flooded basement at the rate of 0.75 liters per second with an output pressure of 3 times 10 to the 5th newtons per meter squared. A. The water enters the house with a 3 centimeter inside diameter raises 2.5 meters above the pump. What is the pressure at this point? B. The hose goes over the foundation wall and loses 0.5 meters in height and winds to 4 centimeter diameter. Now what's the pressure?
So I got 3.25 e to the 5th newtons per meter squared. Don't ask how I got it, because I can't read my own handwriting.
I don't know. That was the only one I didn't do.
What'd you get, Whitney?
I didn't do that one either. I didn't know how to do that one.
Yeah. So I got 275,500 newtons per meter squared.
You're probably right, because I'm not confident in my answer.
So the tricky thing, and I'm not either, because I wasn't sure if the diameter really mattered with the change in pipe. So I just found the pressure at the bottom of the pipe, or no, at the top of the pipe. And you just do that. So you do the density times the gravity times the height. And you subtract that from the total pressure. And you get a lesser pressure at the top.
Perfect. Sounds good to me.
So then B, did I even finish B? I think so. What did you get for B?
B, I got 1.25 e to the negative 3rd meter squared.
Negative 3rd? So I got 223.04. And that one was kind of sketchy on. So
I don't know.
So the way I thought about it with B is you're changing the pipe from 3 centimeters to 4 centimeters. So the pressure. So I just set up like a basic ratio of a 3 to 4, and so I got a different pressure. I don't know.
Seems logical. So you take the pressure from what would be at a 3 centimeter diameter, basically convert that to a 4 centimeter. Increase the 5% or something like that.
Yeah. So that's what this is right here.
Yeah.
So I said like here's the pressure at 3. So I need to find the pressure at 4.
Right.
So it's just a simple ratio. And then using that, then I can use the same formula to find the difference, because you're only going 2 meters instead of 2.5 meters. So then you subtract this one minus that difference.
Okay.
Possibly.
Yep. Best answer we got. So who's are you going to turn in? You get a master sheet.
Well,
But you're
here.
according to me,
I can just scan mine in.
I know I got this one wrong. I think I got this one and the last one, 7 and 9 wrong, but the rest of mine were the same.
Okay. So 6 was. So I'll just copy down 6 because I mixed them up.
according to me, you guys.
So this one actually should be A. Because you got 61. Right?
And on 5.
Yeah. Okay, so then for B, mass equals 195 divided by 1,000 kilograms per meter squared to get 6.8.
6.19 to the negative 2 meters cubed.
Okay. Sounds right. Sounds right. Yeah, and then I changed this one. Okay.
And then 47
Okay. And then this one.
I can't see this. I can't.
Yeah. So let's scan these in.
All right, guys. Until next time.
Sweet. Thank you.